Before we go to any of the questions from week 5 lecture, first I will start with a doubt that most of you had in your previous assignment, and also there was a doubt in the previous session that I said that I will talk to the professor and discuss with him and then tell you. That was about that how to get the feed ratio. I mean, what will be the composition depending on the feed ratio? What will be the molar composition of the monomers in the copolymer, right? That was the query last time we were solving. So many of you emailed me that the last problem, let me tell here. So in the last class, what we have discussed, that was R1 equals to 1 and R2 equals to 1, and what will be the condition? What will be the feed ratio, or what will be the monomer composition after the reaction is complete, that we have discussed. So here we told that it is an ideal condition where both R1 and R2 equals to 1, and this is this particular case is the Bernoullian condition. Okay, only in that case, whatever is the feed ratio, suppose your feed ratio is x is to y. In the last problem, it was mentioned as 1:2, but suppose I am writing this in general, x is to y. So the concept of Bernoulli polymerization was that if R1 and R2 both are 1, then the feed composition will be the final composition of your copolymer as well. Okay, final composition. So that's why we said last time that monomer composition will be, for x, the molar composition will be x divided by x plus y, and for y, that will be y divided by x plus y. That's why we got two answer. Like there, it was 1:2. Forgive the writing of 1. Okay, it was like 1:2, and we got one was 1/3 and another was 2/3. That was the answer. Okay. Now many of you said that in the previous time also you asked that what will be the case if R1 and R2 both are 0. Okay, I will discuss this in this lecture, but let me clarify one thing. I did not actually remember that this is the R1 and R2 both 0. This was a question from the assignment, right? So please don't ask me directly the assignment question, because those are, you are supposed to solve this, right? Because you still have one day left after I discuss this session, so you still can go back and write the answers in that case. So that is not the purpose for assignments. So please don't ask direct question from assignments. After you have given the answer, I can tell you obviously, but that was a direct assignment question. I did not remember last time. Okay, so don't do that. That will not be right. Okay, if I tell you the answer here, that will not be correct. Okay, so moving on to the case that R1 equals to 0 and R2 equals to 0. This was the problem that you were given, and the ratio was 1:2. Two monomers were there and their ratio was 1:2. Now many of you wrote in the last problem, ma'am, we got the answer was 1/3 and 2/3. Then why in this case the answer was 0.5? In the assignment it was given 0.5. You are asking why it was 0.5. So first of all, we have to see that what is the, under this condition, particular R1 and R2 equals to 1. This is the ideal condition where you get exactly what you are putting in the feed ratio. But in case of R1 0 and R2 0, this is not an ideal condition. So first you have to consider what kind of polymer it will form. Because R1 equals to 0 and R2 equals to 0, so what will have? R1 equals to 0 means M1 will not react with itself, rather it will try to react with M2, right? Because R1 does not want to react with a monomer that is like itself. Again, R2 equals to 0 means M2 will not like to react with a M2 monomer. Instead, it will like to react with a M1 monomer. So this is the case for R1 0 and R2 0. So in this case, you are getting an alternate copolymer, right? This was your answer. First, you know that we are ending up with the alternate copolymer. Now, if you are ending with the alternate copolymer, that means alternatively these are matching. Suppose their ratio was 1 is to 2. But how much the reaction can go on? Suppose there was 5 M1 monomers and 5 M2 monomers. Okay. One, I'm just taking a ratio, sorry, 5 not 5. Suppose that should be, this should be 5 monomer and another should be 10 monomer. This is for M1 and this is for the 10 is for M2. Okay. Up to this you should understand. Now there are 5 M1 monomers, so the reaction, how the reaction should proceed? There should be one M1, the next one should be M2, fine. The next one again should be M1 and M2. This way the reaction will proceed. But how long this can go? Up to when 5 M1 are consumed. Suppose after 5 session, let me write it here, M1, M2 and so on, like there is another M1, M2, 1, 2, 3, 4. Okay, now suppose let me write M1, M2. So this should be the composition of the final polymer that you are getting. Now see, up to this the polymer can form because there was 1, 2, 3, 4 and 5 M1 monomers are consumed. Okay, after this there are still 5 M2 monomers left in the reaction. That is fine, but R2 is equal to 0. That means it can't react with itself. It doesn't want to react with itself. So as soon as the M1 is or the M2, either way, as soon as that one monomer is consumed, the other can't react with itself to carry on the polymerization reaction. So whatever ratio you take, suppose you are taking 5 is to 10 or 5 is to 20 or anything, after 5 M1 is consumed, the reaction cannot proceed. So you will end up with a copolymer or alternate copolymer composition where you have equal number of M1 and M2 independent of the feed ratio that you are giving, right? It doesn't matter if you are putting 10 M2 or 15 or 20 M2. Once the M1 is finished, there is no purpose of reaction. The reaction won't go on. Okay, the polymerization won't go on. So you will always end up with the alternate copolymer that has equal number of M1 monomer and M2 monomer. So your feed ratio and the final, whatever is the feed ratio, your final copolymer composition or the molar composition will be 0.5 because they are in equal number. So 5 M1 and 5 M2. So 5 divided by 10. So that should be half that will be happen. Yes, 1 by 2 and that is equals to 0.5. Okay, so that should be the answer. I hope the whether 1, 2, 3 or 4, 5 in 1 hour. Okay, Shesha, I just discussed this thing in the first half. The same problem that you are telling us that you did not get any marks because you did not put the brackets. I just discussed this. Once this session is over, I will upload the video and you can check it there. Also, I will post a message in the group as well. So yes, I have already discussed it. So you can look at it after the session is done and I upload the video. Okay. So back to the problem. So this should be the answer for your problem in the assignment. Okay. Now let me see another problem from this particular thing as well. 1 second. So coming to the next part, last time also somebody asked, so now we are done with what will happen in case R1, R2 both are 1 and R1, R2 both are 0. We are finished with this. But suppose they are different, like there are many other conditions, right? There are many other conditions like where R1 was greater than 1, R2 was also greater than 1, R1 was less than 1, suppose greater than 1, R2 less than 1, like this. There are many conditions like this as well, right? So suppose we take this particular problem. other cases. So it states R1 is greater than 1. Okay. So M1's tendency to reacting with itself is greater than M2's reaction with another similar M2 monomer. If you have any queries, please write down in the chat box, okay? So that after I discuss this problem, I am reading the chat box, okay? So you feel free to write there. If you have any query, please write there. I will tell you the problem, okay? First, let me finish this problem and then I'll read it, okay? Okay, fine. So suppose we are taking this condition where R1 is greater than 1 and R2 is less than 1. So whenever we are going to make the polymer, what happens? As R1 is greater than 1, so initially most of the M1 will be consumed. When M1 concentration is high, most of the M1 monomers will be consumed initially. So at the initial stage, we will get a polymer something like this where M1 concentration or M1 composition is higher. In the middle state where M1 is suppose depleting to a certain amount. After some time M1 is concentration is depleting. So suppose we are getting something like M1, M2, M1 like this, and after once M1 is completely consumed, because it was consumed at the beginning, it was being consumed from the beginning. So at the end of the reaction, what will happen? There will be excess amount of M2. So at the end of the session, you will get something like M2, M2 like this. Okay, this will be kind of your polymer. So you can clearly see, if in this kind of situation, you don't get a homogeneous composition in the polymers. Like initially there is different composition, in the middle there is different, and also at the end there is a different composition. Now in case of that, if you do want to get the composition in the final copolymer, the formula that you need to use, this was also discussed in the slide. Last time I did not get it, but I discussed this with the professor, that this one formula was given like this, where F1 is the monomer 1's composition in the final copolymer, right? And it was like R1 F1 square F1 F2 F1 F2 divided by R1 F1 square 2 F1 F2 plus R2 F2 square. So this was the formula. You can go back to the slide, the formula is there. So where F1 is your composition or monomer 1 in the final copolymer, and F1 is the feed ratio of monomer 1 and F2 is the feed ratio of monomer 2. So by applying this formula, you can actually calculate the composition in the final polymer. You can do that, okay? And also F2 is equals to, suppose F2 is equals to 1 minus F1. So these two formulas were taught to you. But if you think it like this is very problematic, right? So if you are doing an industrial reaction where you are mixing a huge amount of monomers together, this is no way beneficial, because the whole composition throughout the process is different. So, yes, right. Throughout the composition, you get different compositions polymers throughout the process. So if they have different composition, they will have different properties as well. So this is no way helpful for your industrial application. So what they do, suppose they know that M1's reactivity is very high. So they know that M1 gets consumed very quickly in the reaction. So what they do, they make other calculations as well, not just this simple calculation from this formula obviously. But what they do, suppose they know that after certain time, after 10 minutes suppose, they know that the M1 concentration will be decreasing in the whole system. So what they do is they continuously keep pouring the monomer 1 or M1 from outside, so that there is a constant concentration of M1 in that particular reaction mixture, okay? So they are continuously putting M1 in the reaction mixer, so at no point you don't get a concentration deviation. So as soon as M1 is being consumed, you are also supplying from the outside, so the overall composition remains same. They try to do it that way, okay. Or other many other conditions also they apply, like suppose after 30 minutes, after every 30 minutes they keep putting M1. So all this is not just comes from this simple calculation obviously, but they kind of repeatedly keep adding those monomers that are highly reactive, so that you get a homogeneous composition of your copolymer that you are getting at the end, okay. So that is what they do in the industrial field. So I think with this you should be able to do all the problems regarding this, that what will happen, what will be the composition in each cases, fine. So let me move on to the week 5 question. Okay, so let me go to the week 5 session. We'll start with that. So here as well, I think it is 7:30. Okay, by 8 I think we all will be able to solve the theoretical question. They are pretty easy, and after that we will go to the numerical problems of this particular week, okay. Fine. So this is the first question. Tell me the answer in the chat box. Okay. So it states mean field approximation in Flory-Huggins equation should be valid under what condition? Okay. So they have asked this. There is an approximation, mean field approximation in Flory-Huggins. Under what condition that should be valid? Please write down the answer in the chat box. Okay, I have two answers. I think you all know it. Okay. So three answers and three are same. Not spending much time in this question. I will try. Actually, want to move on. So yes, the correct answer was B, because the mean field approximation states that the segments of the polymer should be uniformly distributed in the lattice. Okay. So that can only be happen. The uniform distribution only can be happen when the solution is high with the polymer volume fraction, right? Only in that case you can distribute it equally. If there are only, suppose you are 10 boxes and you are supposed to divide 2 apples in that, how we are going to do that, right? So obviously higher the concentration of the polymer, or higher the polymer volume fraction, the more you will be able to distribute them uniformly. So that is the condition for mean field approximation, and do remember that is one of the drawbacks of Flory-Huggins equation as well. They considered the mean field approximation, but the whole equation was derived for dilute polymer solution, okay. So that was one of the drawback for mean field approximation. Moving on to the next one. This is your second question. It states that solubility parameter approach to find out solubility of a polymer in a solvent works best for the combination of what kind of solvent and what kind of polymer combination is best for solubility parameter approach. Okay, try to remember the what kind of conditions were taken during solubility parameter approach, and you will be able to answer that. Be free to answer that in the I got one answer, okay. B, okay. Those who are answering, thank you very much for answering. But as I've said earlier as well, that the same people answers all the questions. They at least try. It's a good thing, right? They are at least trying to answer. Whether it is right or wrong, that doesn't matter. They at least trying. So all of you should at least try to answer. Okay. So most of them they are saying D. One is saying C. Okay. So let us see the correct answer. The correct answer was D. Why? Because if you do remember the approximation that was taken, like the equation for solubility parameter was something like this. Let me. So this was delta H M equals to V minimum V mix. Okay, phi 1 phi 2 phi 1 phi 2 delta. Suppose I am just writing is a delta square, delta 1 minus delta 2 square, where delta 1 was polymers and solvent, and another was for polymer. Okay, so this was kind of this equation, and this is for Hildebrand equation, right? This was the equation of Hildebrand. From this we get the value for solubility parameters, or the concept of solubility parameter. Now clearly during the approximation it was stated, so the approximation was something like this, that delta H is not equals to 0, but the delta S value, delta S mixing value is equal to the ideal delta S mixing. So this was the condition where we taken the Hildebrand equation. So you all know that delta G equals to delta H minus T delta S. So we know for ideal cases, or delta is 0, the delta is always positive. So in that case the minus T delta S term is overall negative. So obviously the reaction to happen, delta G should be negative as well. So under what condition it can happen? When delta H is either 0 or delta H is low positive value. I mean even if it has a low positive value, but smaller than this T delta S, then also we will end up with a negative delta G value. But it did not consider the interaction between the I mean the entropic factors or the enthalpic factors that comes due to the interaction between the polymers and solvent molecules. Like if there is some kind of interaction like electrostatic or hydrogen bonding interaction, then obviously the delta H value will not be always positive or 0, and the delta S term as well. There will be many factors involved in this case. So they completely ignored that factor and stated that this is mainly applicable for non-polar solvent and non-polar amorphous polymers. Whenever there is a crystalline polymer or there is a polar solvent, there will be many kind of interaction involved in the system, which are ignored for this case. Okay. So let us move to the next one. This is the third question. Characteristic ratio of a polymer chain represents what? Upon these four options, what is represented by characteristic ratio of a polymer chain? Okay, I have one answer. One answer. Okay. Okay. 3. Another one says A and D, C, D. Okay. Thank you everyone for answering. Let us look at the answer. So the correct answer, only one person has given the correct answer. Okay, out of all of you. Even though the others who said D, they are not fully correct. It was a MSQ type of question, right? So both the option A and D are correct. Why? So this is your characteristic ratio of a polymer chain, where this is the definition. The fourth option that I have given here, this is simply the definition of characteristic ratio, that how much greater the RMS end-to-end distance of suppose a real life polymer chain compared to that of a freely joined chain. So in case of freely joined chain, what is the root mean square value? N to the power half into L. That is your value for freely joined chain, and this is supposed your polymers unperturbed RMS end-to-end distance. So you just take the ratio and get your characteristic ratio. And again, this particular ratio means you are actually talking about the stiffness of the polymer. So in case of freely jointed chains, what happens? We are just considering it as a segments that are connected with each other. No static interaction, no long range interactions are considered, or no bond angle restrictions are considered overall, right? So it's just a freely joined chain, there are no restriction. But whenever you are considering a real life polymer or something, in that case this cannot happen. There will be some static interaction, some long range interaction, and bond angle problem. So, uh, how much the in case of freely joined polymer, this will be able to freely move, right? Because it does not have any hindrance when it's trying to move. There is no such restriction in its movement. But whenever you are considering about a real life polymer, so there are coming different kind of different kind of restriction in its motion because of various reasons, right? So ultimately the freely joined chain is very much easy to move, very much free to move. Compared to that, the real polymers are not able to freely move. They are more stiff, right? Compared to the freely joined chains, they are much more stiff because they have many restrictions that are just hindering their motions. So obviously ultimately what you are getting the stiffness idea about the stiffness of the polymer. The more that is the difference, from that you can say that how much stiff your polymer is. If it's equal to your freely joined chain, then your polymer is not stiff at all, right? But if it's very much higher than your or less, in some cases, then your polymers get stiffer, right? So both one A and D, both the options are correct for these questions. And let us move. And end-to-end distance is not correct because it is a ratio, not a particular uh, distance. That is also written in the name of itself, like characteristic ratio. Okay, fine. So this is your fourth question. It states that if the value of polymer solvent interaction parameter decreases the solubility of the polymer in the solvent, what happened to the solubility of the polymer in the solvent? If polymer solvent interaction parameter, it means chi, if it decreases, what happens to the solubility of the polymer? Write down the answer in the chat box. No, I think there are mixed answer, like some are saying C, some are saying D, some are saying B. Mixed kind of answers I am getting. Okay, so let us look at the answer. The correct answer was C, that is increases. Why? So it states that the polymer solvent interaction parameter is decreasing. That means chi is decreasing. So we all know for theta solvent, which is the like an ideal condition. It is like in between the poor and good solvent, just in the between. So in case of theta solvent, the chi value is 0.5. You know that. Now in case of if it decreases, like chi is less than that, like it states the parameter decreases. Suppose it is less, like it is getting like zero point 0.4. If it less than zero point 0.5 or it is decreasing, then obviously see, we are placing like zero point 0.4 minus 0.5. So we are getting a negative overall value for this, right? A negative overall value for this means this is nothing but your delta G, that is represented as chemical potential of the solution. So your chemical potential or delta G is becoming negative. The more lesser the value of chi is, the more negative the delta G value gets, right? So the more delta G becomes negative, The solubility should increase. The solubility of any kind of thing depends on what? The sign of delta H or the delta G, I mean, and the magnitude of it. If it's higher in magnitude in the negative quantity, so obviously the solubility will be increasing. So the more you decrease, the more it will be negative, right? It will get more negative. So the delta G value will be more negative. So obviously delta G is more negative means solubility will increase. Okay, so let's move to the next one. This is, I think I have already discussed this. There is no point of discussing this question. I'll just go through the value of polymer solvent interaction parameter for which the solvent behaves like an ideal solution. So you all know that delta G is equals to 0 or the chemical potential difference is equals to 0. So that is your ideal condition, and that happens when chi equals to 0.5. I just discussed this in the last question. So let's not go to this. Yeah, I am sure you all will know that. Okay. So this is the question number 6. So a similar type of question is given in your assignment as well. And thanks to Arjun, he pointed it out that the phases that was mentioned in there was a problem with that. Like inside the car, there should be two phase, and outside it there should be one phase. So that is a problem in the question. Otherwise you all can actually select the correct answer as well. That should not give you much problem, but there was a mistake in the diagram that was given, and thanks to him that he pointed it out, and I think I have posted a message regarding that as well in the group. Okay, so tell me the answer. This is the following phase diagram. T1 and T2 are shown here, like this is T1, this is T2. So what will you call them? It is asked. Okay, what will you call them? What is T1 and what is T2? I have one answer C, two answers C, and two answers D. Okay, another I got C. Okay, T1 and T2. Again someone is saying D. Okay, so still I think people are confused about this concept, right? They are still giving a different types of answers. Some are saying C, some are saying D. Okay, so I am getting mixed answers. So let me clarify this question well, so that you don't have a problem in your assignment as well as in your exams as well. Okay, so first of all, the correct answer was C. Okay, so those who answered C, I think they understood the phase separation process properly. For those who have a problem, first of all, let me say a very simple thing to understand. Okay, just to and for answering the question for this purpose. So in one case we get a curve like this, and in another case we get a curve like this. Okay, these are the only two conditions that we are getting, and when we mix these two we get something like this. So mainly there are only these two types of option. So see, which point we are most concerned about? This point and this point. Every time we are concerned about these 2 points. Now those who are having problem to remember, just think in this curve, this particular point that you are considered about, where the phase becomes like 1 at that particular concentration, where the point resides. It is in the lower part of the curve. Simple. So this will be LCST. Just remember the name. It states lower critical solution temperature. That means whichever resides at the lower part of your phase diagram. So that is your LCST. And UCST means upper critical solution temperature. So when this temperature or the critical temperature appears in the upper part of the curve, right? So this is your upper part of the curve. So whenever this happens, that means that is UCST. This is just for the, so that you don't get confused and can easily answer. So basically LCST is what? When you increase the temperature and the polymer separates out from the solvent, I mean from one phase, as you gradually increase the temperature, it separates out from the solution. That is your LCST. Okay. So below a temperature, it remains soluble, but as you increase temperature, it gets insoluble. This is just opposite in case of UCST. So UCST type of polymers, they remain soluble in the solvent initially, but as you they remain insoluble in the solvent initially in case of UCST polymers, but as you increase the temperature, they slowly starts to get soluble, and after the critical temperature they become soluble. Okay, so this is the basic thing for LCST and UCST, and I have also said you how to just remember. Lower means at the lower part of the curve and upper means at the upper part of the curve. Just if you remember that, you can answer all the question. Fine. So let us move into the next one. Okay. So this is the next one. It states the behavior of polymer chain in a good solvent. Okay. Just remember, it's stating a good solvent can be related to expansion factor and chi. So what will be the condition, like in a good solvent, whether the polymer will be soluble or insoluble, and what will be the value for the expansion factor and polymer solvent interaction parameter chi. Okay, so what should be the value? Try to select an option from them. Remember that we are talking about a good solvent. So I have one answer. He says C. Okay. Another. Don't forget that it is a good solvent. So some answering C, some are answering D. Okay. Again a mixture of answer. 7D. Okay. 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 So let us see the answer then, and I will describe or discuss this as well. So many of you answered correctly. So the correct option was D, but many of you did not. Okay. So many of you stated that C option is correct. So first of all, let me come to it one by one. So the first thing is it is a good solvent. So obviously from the name it is very obvious the polymer will be soluble. So these options are already not valid at all. It's a good solvent. Okay. Next thing I see, you know that in case of good solvent, what is the value for chi, right? So those who wrote the option C is correct. See, chi equals to 0.5 is only for theta solvents or theta temperature, like theta condition. That is the ideal condition. That is not a theta solvent and good solvent are different, right? Theta solvent is in between those, poor and good. Whenever it is good, just in the previous problem we discussed that chi value has to decrease so that the polymer becomes soluble in the solvent. That means chi value has to be less than 0.5. So only in that case the delta G value will be negative and your polymer will be soluble. So as it a good solvent and as it solubilize the polymer, so obviously x has to be less than 0.5. So this option is not correct, this option is not also valid, and I think we are left with two options. Sorry, yes, where I think only two options are we are left with. Okay, now we know that it is soluble, x is less than 0.5, and the next part is polymer expansion factor. So what is your expansion factor? You already know that, like you write down something like if it is your root mean square value, it is equals to the expansion factor into the root mean square value of your unperturbed condition, right? So if it is a theta solvent, that means it does, the chain of the polymer does not uh, extend in the solvent, right? It is not re-interacting with the solvent nicely. In that sorry, I mean, if it's a poor solvent, it is not interacting with the solvent nicely, so it is not expanding in that case at all. Yeah, so if it does not interact with the solvent, what it will try, it will try to contract itself. So what should be the your ideal size in a suppose theta condition where there is neither a good interaction nor a bad interaction is happening with the solvent. So suppose this is your point 0.5 case, but now you have put something like poor solvent, then it will try to contract itself, right? Because it does not want to interact with the solvent, it is not a proper solvent for it. But the question was for good solvent, so whenever it is a good solvent, that means the polymer segments are interacting with the solvent molecules properly. So the chain that we are getting, it is now kind of opening. Okay, it will be something like that. So there will be an expansion overall, right? So there will be an expansion in the root mean square value or hydrodynamic volume or anything, right? So whenever you are using a good solvent, this parameter should be greater than 1, because you are getting this higher than your ideal condition. If this one is your ideal condition for 0.5, then in case of good solving, you are getting higher than that, so alpha value should be greater than 1. So do not confuse it from in the assignment or in the exam. This is just the concept. Just remember the concept, what happens whenever you put a polymer in a good theta or poor solvent, then you can answer all these questions. Okay, let us move to the next one. Okay, so this is the next one. So another query I think I got from Arjun as well. So he stated that the value for the polystyrene that was given in the question, I mean solubility parameter that is given in the assignment, is not matching. So suppose first of all that is a, like an arbitrary question, like that is not like a proper example or a real life example. That was just a for your understanding, that if we change the value and if we change the suppose polymer and give you a different value, will you be able to understand from the chart that what kind of solvent you have to use? So that is just an arbitrary value that is given solely for your numerical problem. So just consider that as well and solve the problem. And another thing was in the assignment it was polystyrene written here, and here it was written as PMMA. So it was just a typing mistakes while the questions were made. So the whole question is only about polystyrene in case of the assignment. Okay, so do not be confused with this. The whole question about polystyrene, just whatever is stated for polystyrene's delta value, just consider that and answer this. Okay, just do not be confused with any other things. So first answer this question. The value of solubility parameter for PMMA is 20 joule to the power 0.5 centimeter to the power minus 3 by 2, or it is written as megapascal, right? So which of the following solvents is expected to be the best solvent for this polymer? So this is your chart. Look at the chart and tell me which should be the best solvent to solubilize PMMA. Okay, when the delta value for PMMA is given as 20. Okay, so there are many answers. Thank you for answering. Many are saying acetone, someone is saying chloroform. Okay, acetone medium, hydrogen bonding. Okay. A, D, also I think. Okay, fine. So most of you are stating the correct answer is acetone, and you are correct. So what you need to do, you need to just consider this Hildebrand equation that we take, and we know that the lesser the value of delta 1 minus delta 2, the lesser the value will be for delta H. So that will be, the more less positive the delta H value is, that is better for your negative delta G, right? So we just have to check in which case you have the minimum difference between the polymers and solvents solubility parameter. So who answered chloroform, see there is another answer, acetone 20.3, so the difference is just 0.3, right? But in case of chloroform it is 19 minus 21. So suppose if acetone was not here in this chart, if it was not given, then your answer could have been correct, that chloroform was the correct answer. But for this particular case, you see this difference is much less than in case of your chloroform, right? So the correct answer should be acetone. Fine. So let us move to the next one. Okay. This is a numerical problem. We will solve it, and then after that let me take some minutes of break because I'm constantly talking. So let's first solve this question. Okay. So in terms of lattice model of fluororeagents theory, the number of segments per polystyrene molecule of molecular weight of 10,000 dissolved in toluene and 25 degrees C is, you have to get the number of segments per polystyrene molecular which have a molecular weight of 10,000, and what values you have here. Polymer density is in toluene is given, and toluene density is also given. So you have to, basically you have to get the number of segments value. You have that Fluoriagens equation, you have a factor called x, right, where you just get this by dividing the volume fractions of polymer and solvent. So they are just asking you to calculate this value for x, or number of segments, or this is also sometimes known as, in this particular case, degree of polymerization as well. Okay, try to solve it and tell me the answer in the chat box, and then I will discuss. Number of segment is just is equal to the ratio of the molar volumes of the polymer and the solvent that you are using. I have given, okay, I have got one answer. Okay, it is stating age 64. Okay, others also please try. I have already given you the hint while deriving the Fluoriagens equation. We considered a parameter called x, where it was just the ratio of molar volume of, say, polymer and molar volume of your solvent. You just have to calculate this V2 and V1 for individual case, and then take the ratio, and you will have the answer. Okay, so we have two strikingly different answers. One is 864, another is 2038.7. Okay, so others also, let others also try. At least if I get 2 to 3 same answer, then I can show you this, that how to solve this. Eight 65. Okay. others also write. Those who are correctly answering the questions, I mean theory questions, they should be able to answer this as well. So far, only three answers I have here. I have given you what to find out, which formula you have to use, what you have to calculate. I have stated everything, and you have all the necessary information that you require. You just need to calculate molar volume, and you do know the mass of the polymer, and I mean molecular weight of the polymer, and the solvent you do know, or else you can calculate for toluene. You do know the density for both polymer and toluene. So calculating volume is very easy, right? Rho equals to m by v. That is the equation. So v will be m by rho. You know the m values, you know the rho values. So why there is only three answers? I have written down the equation. I'm telling the solution even constantly that you have to calculate the molar volume, and the simple thing is V is equal to m by rho. So all that you need to do is calculate your m2 by rho 2 and m1 by rho 1, and you will get your x value. No one else. This is probably the easiest mathematical question from this session. Okay, fine. Let me show you the solution. So the correct answer range is between 850 to 875. So those who said that, they were very much correct. So let us see that I have already told you that you have to calculate the number of segments or degree of polymerization. That was the basis for Fourier's theory, right? We are taking the value or calculating the value for the number of segments per polymer chain. So that is given by the molar volume ratios of your polymer and solvent. So first let us calculate the molar volume for polymer. So you know the molecular weight is 10,000, 1 lakh. 1 lakh is given here. So and you know what is the density. So you just have to do m2 by rho 2, and you will get the molar volume something like this. In the next step, you have to calculate the molar volume of toluene, right? So you know that, or else you can calculate the molar, I mean mass or molecular weight of toluene as well, right? Everybody knows the structure of toluene. So this is 92.14, and this is your density. That is also given in your question. So just divide those two, and you get your molar volume for toluene. So once you get both V2 and V1, you just need to take the ratio of them, and you will end up with a value something like in between 850 to 875. Okay, others who still have doubt can see this problem. I think a similar problem is given to your assignment as well. So make sure you do understand the problem, that what this question is asking, what formula we are using, and how we are using. Okay, so that you will be able to solve the assignment problem. So yeah, two of you are correct, and okay, the third one you are not correct, but at least you tried. I'm happy for that. So before moving to the next question, let me take some moments to uh, get some energy back. Okay, write the step. Could you please write the steps for the previous question? Do you mean this question number 9? Can you write it in the chat box? Do you mean that you want to know the steps for question number 9? No, question number 8. Okay, so let me show you the question number 8 again, and then I will take the break. Okay, so this was your question number 8. So it has asked you to state what solvent will be best to solubilize this PMMA polymer, where the solubility parameter for your polymer is given as 20 megapascal. Okay, this is the solubility parameter, and there is a chart of solvents where the individual solubility parameters corresponding to these solvents are also mentioned. Fine. So, if you do remember the Hildebrand equation, then you know that just I have stated in the previous problem as well, that as for Hildebrand equation, we take the assumption that delta S is the ideal one. So delta S is always positive, but you need to the delta H value should be either 0 or low positive or less than T delta S, so that you overall get a negative delta G value. Okay, so the lesser the difference between this value, I mean lesser the difference between delta 1 minus delta 2. One is for polymer, another one is for your solvent. Okay, so if this difference is less, then the square will also be less, so your delta H value will also be less. So your whole purpose is to reduce the delta H value. So for that, what you need to do, you need to reduce this difference in the solubility parameters. So now look at the solubility parameters. Your polymer solubility parameter is 20, and look at these values, in which case you get the least difference. In case of acetone only, this is the case where we only get a difference like 0.3. So obviously that should be your, in all other cases you will have a greater difference that will lead to a greater delta H value. So obviously the acetone will be your correct choice for this question. What will be the pattern of examination? Pattern of examination, there will be similar question like you are solving in the assignment as well. There will be MCQs, there will be MSQs, and there will be numericals. These three types of questions will be there, but they all will be mixed. Okay, it's not like you will get the numericals first or the MCQs first. This is not the way that the exam will go on. You will get a mixture of all those questions, so you even don't know that uh, which one will appear after one. Okay, it's just a mix of all these three types of questions as well. Okay. Okay, so before going to the break, okay, so polymer chemistry actually is not that easy as well, and when you actually speaking about the basics of polymer chemistry, right, here we are discussing the polymer chemistry or the equation that are actually used in the industrial purpose. It is not fully like the application or the research purpose. It is fully like the industrial purpose. So don't worry, it is even difficult for me sometimes as well, but I try to go through the videos that Professor Dhara has given us. I try to go through them numerous times, and then I try to understand the whole concept. So the main thing is you do please try to understand the concept. If you do not understand what is happening, you will never be able to solve any numerical. Okay. So if you have any doubt, you can you are always free to send an email to me, because I have this option to talk to the professor, right? So even if I can't solve your doubts, I can directly talk to the professor, and we can discuss, we can understand the where the problem is, and then I can get back to all of you. Okay. No, there will be a calculator provided. Okay, there will be an online calculator that will be provided, and I think before the exam they will send you the all instruction. But there is a calculator available. I know that. So there will be an online calculator. Okay, so please no, there will be an online calculator. You will not be allowed with a external calculator inside the exam hall. It will be just like the NET and GATE exam nowadays, and JAM as well. You just have an online calculator. You calculate your numericals there. Okay. So okay, fine. So please let me take at least a 5 minutes break. I will be back at 8:15. Okay. So let me take a 5 minute break. I'll be back. Meanwhile, you can try to go through the equations in week 5 lecture. That will be very much helpful to solve the next problems. Okay. So I'll be back at 8:15. Okay, so let us resume the session again. I think I'm already presenting. Okay, so let's go back to the question. Uh, okay, so you all are able to see the slides, right? Please confirm that in the chat box that are you able to see the slides? Okay, fine. So let us.
Hello, madam.
Yes, yes,
Hello.
yes. Yes, I
Shall
can
I
hear
speak
you.
to you for 5 minutes?
Can you please write your query in
Hello.
the chat box because we have to solve the question as well. I will definitely answer your question or what you need to say or ask. But let us first solve the question because then I can talk to you, right? First, let's go through the question. You can always I will come back to you. You can just write down what you want to say, or at the end of the session you can also talk, right? So let us first quickly do the question, then after that we can talk. Okay, I will come to you, no problem, but let us first quickly finish. There are many numerical problems in this session, so please, I will come back to you. Okay, so let us move on to the next question. So it states that ratio of 1 second, let me the ratio of contour length to random coil RMS end-to-end distance of polyethylene of molecular weight this much, okay, 1.4 into 10 to the power 5. What will be the ratio of the contour length and RMS end-to-end distance for a polyethylene molecule of molecular weight of 1.4 into 10 to the power 5? So you already do know what is the contour length, right? So what is the formula for contour length and what is the formula for RMS end to end distance? So if you both know those two, so just you have to calculate the value for n, number of segments, and as it is polyethylene, so there is like CH2, something like kind of this involved, right? So you know this L value, even I am saying it, suppose the L value should be 0.154, I guess. Okay, so if you know all this, you need to calculate the n value, the number of n, and then you can both apply the formula for contour length and RMS end to end distance and get the ratio. First try to solve it by yourself and then I will get back. 15.4. Okay, I have got one on answer. That is very quick. Thank you. I don't know whether it's correct or not, but thank you for answering it quickly. You know what is the value for your RMS end to end distance then for random coils and your contour length as well. You would not need L, I guess. Okay, so two different values again. One is saying 15.4, another answer is 71. Okay, let us see what others are getting. And do not forget to ignore the contribution of the chain ends during the calculation. If you do not remember, go to the slides and see what is the formula for contour length and for RMS end to end distance, I mean CRMS, and what is the value for contour length. And then it is very easy. The molecular weight is given, you just have to calculate the number of bonds, number of segments. It is simply just polyethylene, so there should not be any problem in calculating the value for N as well. it's polyethylene, so it is again very easy. You can look at the slides as well, as it is not an answer. So again another different answer I am getting. So three answers so far I have got, and three are different. Let us see which one will be correct. Others also, I have given all the hints in this question that you require to solve this one. Okay, you just use the formula for contour length and end-to-end distance, and then take a ratio. You just need to calculate in the molecular weight is given, and you know it is a polyethylene, so you can obviously calculate the number of segments, as you are not uh, taking the chain end, so it is more easier. Polyethylene means just CH2 group is repeating. Okay, so okay, you changed your answer, fine. Okay, so now I have two answers that are closely matching. Fine, so let me show. Okay, another answer. Thank you very much for answering. I'm very glad. So let us see what the answer is. One second. No? First, let me remove this. So this is the solution. Let me first show you the full solution and then come back to it. So as I have just said, you will not even require to know the L value for this particular problem. But please do remember the normal CC bond, I mean CH to CH2 bonds distance. Okay, in other cases you might require it. For this particular math you won't be requiring as you are taking the ratio. So let us come. Contour length equation is nothing but like segments are just jointed to each other, freely like jointed to one another. So if there are n number of segments and they have the length L, each segment have length L, then the contour length is n into L. And this is your RMS end to end distance, that is n to the power half into L. So once you know the formula, you obviously do know that you have to take a ratio, that is n divided by n to the power half. L's are cancelling, so we are not bothered with the L values. So that will give, the ratio will be n to the power half. Okay. So this far you know. Now you all that you need to do is to calculate the number of segments or number of CH2 groups in this case, because it is only a polyethylene molecule, right? So you just need to calculate N. So this is your molecular weight. 1.4 into 10 to the power 5 is your polyethylene's molecular weight. Now you know that polyethylene is consist of only CH2 groups. It is like CH2 whole n. We can write this. Already they have said that ignore the chain ends calculation. So we do not need to know what is there in the chain end. We can obviously ignore them. And in the middle, we only have CH2 whole n, and you have to get this number for n value. So what is the molecular weight for each CH2 unit? That will be 12 for carbon and 2 for hydrogen. So 12 plus 2, that is 14. So how many segments will be there? If the whole polymer molecule is 1.4 into 10 to the power 5 and your each segment weighs 14, then that will be just, if you divide them, 1.4 into 10 to the power 5 divided by 14, that would be your number for, or the value for n. So that will be 10,000. But in the case, you know, the n is the number of bonds or whatever I'm taking, the segments. Now just for example, let me say suppose we have 5 CH2, or suppose, let me take a smaller number, that will be easy. Suppose we have 3 CH2 groups that are joined with each other. So this is CH2, CH2 and another CH2. We are not considered about the end groups, so I am not bothering about the what is in the end group. Fine. So suppose if we have 3 CH2 groups, so what is the number of bonds? there is one bond and two bonds. So obviously for three CH2 groups there is two bonds, right? So if there are n number of CH2, there will be n minus 1 number of bonds between them, obviously, right? But I am just giving an example like 3. But in case of polymers, you can already see the n is 10,000. So even if you minus 1 from that, that doesn't make much of a difference in the whole value, right? You just subtracting a single bond from 10,000 bonds. So that doesn't even vary your calculation much. So it will be almost equal to 10,000. Do not take it like it is equal to 10,000. It is written as it is almost equal to 10,000. So this is your n value. Even if someone puts 10,000 minus 1 and then calculate it, that is also right. Okay, that is not wrong. But if someone does like that, that is also fine. So now it is your n value, and you know the ratio is n to the power half, so that will be 10,000 to the power half, and the answer will be 100. Okay, don't we have to use ch2 madam? Yes, you are right, I have just discussed it. Okay, fine. So let us move to the next question. In the previous one, and I just showed you all the formulas, so I am very much sure you all will be able to solve this. So they have asked, what is the RMS end-to-end distance in nanometer according to the freely jointed chain model of polyethylene of molecular weight 1.4 into 10 to the power 6. Same thing, you need to calculate if the RMS value you already know, that is equal to n to the power half into L. So first you need to calculate the n value, just similar to the like I have showed in the last problem, and the value for L I have stated in the last problem as well, that will be 0.154. In case if you do not remember, I am writing it down, but make sure to remember this value, because I don't think this will be provided in your, it might be provided, but I'm not sure if it will be provided in your exam. So make sure you do remember the bond distance between the CH2 values. Okay, I have already two answers, but again two are different. Okay, so this is just calculate the CRMS value n to the power half into L. Calculate the value for n and then root it and multiply it by L. We have just discussed the problem, so I think thank you for those who are answering. They did answer the last question as well. I think the same people answered the, yes, same people answered the last in the last question as well. I have just shown you the solution for the last one, right? So you should be able to calculate in n in this case. Okay, so if you know n, just do a root and multiply it by L. I have said the value for L even. Okay, some, and it is stated in nanometers, so be carefully. 48 or 154 and 15.4. I think some basic things are missing here. Okay, it's n is the number of bonds. If you do take ethylene, then the number of bonds are not same. As simple as that. You are taking ethylene, suppose I just gave the example like there are 3 CH2, then you are just taking suppose CH2 bond CH2 one segment, and another segment is left with just CH2. So there is only one bond between them. First of all, that is not the segment. That is not the repeating unit. So what you are talking about, that is not your particular segment. So obviously, if you take ethylene, it will not be your number of bonds. You will not be able to calculate the number of bonds. Ultimately, you have to calculate the number of bonds. That's why you need to understand the segments. What is the segment same? Okay, so very different is 48, 49, something like that. Another group of people are answering like 15 or something, and some answer I got 154, 182. Okay, so the correct answer was 48.7 nanometer. So I'm not quite sure that why there are so many different values. So I think you can check it out from the solution. Sorry. Okay. So see, the number molecular weight is given similar to the last problem. Here CH2 is 14. So when you divided that, you already know that is your 10 to the power 5 number of CH2. There are 10 to the power 5 number of CH2 present. So the number of bond, obviously here again you just subtracting a single bond n minus 1, so that doesn't even give a big difference. So it will be around 10 to the power 5 as well. And length of each bond L 0.154 nanometer. Make sure to remember the value from the next problem, and you just have to then do n to the power half into L. If you do that, this is supposed to be your answer, and I think most of you got that. Name is applicable for other monomers also. Yeah, name is applicable. Name is based on the repeating units and everything, so that is a total different thing. That doesn't mean, or that doesn't specify the number of bonds, right? Like your this particular doubt will be cleared in a I think some problem I have here in this session as well. You will be able to understand. Just by the name you cannot understand how many bonds are there. For that you need to know the structure, right? Fine. So this should be the answer. Just check it out where some of you got it wrong, that you got 182 or 154. Just check it out, but the value should be 48.7. So this was the range that was given. Okay. So let us move to the next question. Okay, so what it states, the osmotic pressure measurement of polystyrene solution in dichloroethane yielded the value of second virial coefficient A2, right? The second virial coefficient that you have read, all of you, when you are mixing the Flory-Again's equation with the specific viscosity or intrinsic viscosity value for calculation, right? And you get a second virial coefficient A2 there. So what is the value for polymer solvent interaction parameter? So if you do not remember the formula for A2, you can go back to the slide. There is a relation between this second virial coefficient and chi, right? If you see that, if you find out that particular equation, it will be easy for you to understand or give the answer for this question. So see, one thing I must mention, that the formulas that I am using either in the the formulas that are coming up either in the assignments or suppose in the session that I am discussing, where you need to remember some formulas, right? You don't always need to remember all the formulas that there was discussed there, but there are some specific ones that you need to remember, because obviously you cannot get to solve the equation and then get the answer for the numerical problems in the exams, right? You can do that for assignment, that is fine, but not for exam. So remember to whichever formulas we are discussing in the session or in the assignment, make sure to remember them, okay? So that you don't need to, you can't go through the slides in the exams at all. So you need to calculate the chi value, where the A2 is given, and what else is given? Molecular weight of polystyrene is given, density of polystyrene is given, and density of the solvent is given as well. Okay. So all the things are actually given. If you do find out the formula, you can see all the values you require are provided in this numerical. just find out the relation between the second virial coefficient and chi. You can go through the slides and then answer. Okay, I already have one answer. Okay, others also can take your time. Okay, I have got two answers. Very good. Let's wait for others to find it out as well. Because even if you are looking through the slides, you should have the knowledge that where you need to look for the particular formula, right? So if you haven't understand that, you will not be able to find a formula even. So let give others some time for find it as well, and then I'll show you the solution. Okay, 0.47 to 48, very nice. I have already got three answers. Very good, but not very good. I mean, only 3 out of 30 or so. Okay, so far the one good thing is every answer are kind of same. I mean, all are stating similar answers. That is fine. Okay, fine. Let us see the solution if you are able to find it. So this was the relation between your second virial coefficient and chi or polymer solvent interaction polymeter parameter. So D1 is the density that you require for your solvent that is provided in the equation. M1 is the I think the mass, and D2 mass of the solvent it should be, and D2 should be the density of the polymer's density is also provided. So I think the molecular weight of the polymer is not even required to solve this. Okay. So this should be the correct answer. So this is on your D1 value, that is the density for your solvent dichloroethane. D2 is the density for the polymer, that is polystyrene. We have it here, and the second virial coefficient value is this. We just need to put all these things into M1, D2 square and D1. The only thing you need to calculate here is the M1 or the solvent's molecular weight. Solvent is dichloroethane. It is already stated. So you know what is the structure of dichloroethane. So you can easily calculate that from there, and you will end up with a value like 0.474. So just tell me one thing that is not included. So what kind of solvent then this dichloroethane is for this particular polystyrene polymer? Okay, what kind of solvent then this dichloroethane is this? You have your chi value, right? If we all have understood the problem that we have discussed earlier about chi, then you should be able to say it like what kind of solvent is dichloroethane for polystyrene? Okay, from the chi value. What do you think? Okay, so very the thing is, those who have answered, I already know that you do understand this because you are all able to answer those previous questions even. So your concept is already pretty clear, I guess. So anyway, the obviously this was a very easy question. So x or chi is actually less than 0.5. So whenever it is less than 0.5, it is must be a good solvent. So in this case, dichloroethane is a good solvent for polystyrene. Okay, so this is the next question. So it states, consider water vapor behaves like an ideal gas. Okay, calculate the solubility parameter. I mean, solubility parameter means your delta. You have to calculate delta of water at 25 degrees centigrade, and which values we are provided with, rho and molar enthalpy of vaporization for water. I mean, delta H, Vm. These values are given, temperature is provided, density is provided. You need to calculate the value for delta considering it as an ideal gas. Now, I know you will all go to this Hildebrand equation. but there is a particular formula, I mean particular version of that formula when it comes to ideal situations or ideal gas condition. So you need to apply that one. Okay, so make sure to use that particular formula for ideal behavior and calculate the solubility parameter. Because the normal Hildebrand equation is quite different from the ideal one. So make sure to calculate the use the formula for the ideal one. And once you are done, write down the answer in the chat box. No one is giving any answer yet. Okay, so at least let me tell you the first what formula you need to use, and then I think all will be able to solve. So first of all, what is your solubility parameter? Delta is equal to delta E V divided by V0 to the power half. So this is the solubility parameter where delta EV is the molar energy of the vapor and V0 is the molar volume of the liquid. It is your general delta formula. So obviously if you square it, it is like delta square equals to delta E vapor divided by V0. This is your formula, normal formula. Now you have to consider, or it is also, you know that it is also known as the cohesive energy density, this particular term. Now if you have to consider about ideal gas, so obviously in case of ideal gas, what you can replace this delta E or the energy for molar energy for vaporization, that simply you can replace by delta H V minus RT. Del H equals to del E plus del N RT. That is the equation was there. So del E equals to del H minus RT. So you can simply use that equation for ideal case. For ideal cases, that is the equation, right? Del H equals to del E plus nRT or delta nRT, whatever is there. So in case of ideal gas, the delta is E is delta H minus RT. So that is divided by your V0. Fine. So instead of V0, what you can write? In place of V0, you can write rho by M. So now you have your delta H V value here. R you know, temperature is given, and rho and M is also you know. So you can just calculate it from there. To two very strikingly different answer. One is 1.5 and another is 46,000 to 47,000. So very different answer. And do not forget this, okay? In what unit you need to calculate, that is also mentioned here. So whenever you are putting the value for R, you have to make sure you have put the correct value of R in the correct unit. Okay, is joule meter to the power minus 3. So make sure you put all the values in joule, right? Don't forget about converting the kilojoules to joules, and make sure you put the density in case of gram per ml, that will be different as well. Kg per meter cube you have to do instead of gram per cc. Also you have to put correct value for R as well in SI unit. So all the things you have to put in SI unit. So if both of you are getting so different value, I think this is due to some miscalculation during the unit conversion. Make sure you put all the values in SI unit. Delta H V is 40.7. So please do consider to convert it to joules. It is in kilojoules. So make sure you convert into joule. Then put the value for R in SI unit. Temperature doesn't matter. And in case of rho by M, make sure you put the value for rho in kg per meter cube instead of gram per cc. And mass of that also, mass of water is also in kg. Okay, so next answer is 1455.025. That is also strikingly different answer. So all the three answers are quite different. Okay, so others also please try to answer, and then I will show it how to solve it. I got another different answer. There is 47.47. If at least two values match, I will show you the answer. But till then, let's see what others are getting as well. See, I can show the answer, but that will not help, right? You should be able to do it by yourself, then it will also make you happy. Okay, then I got the correct answer. And even if you don't, you will know what the problem was. But at least try. In question number 11, you just need to calculate molecular weight of toluene. The question is in question number 11, how you will find M1 value as 99 gram per mole. So I don't remember if it was toluene or not. You just calculate the molecular weight. If it was, I don't remember it. Let me calculate it. 6 times 12. Um, 84. 84. 1, 2, 3, 4, 5. 8. 84. Around something. I will see the question 11. Okay, I will see it. Currently, I don't remember what was the solvent or what was. We just simply needed to calculate the molecular weight. I think I currently don't remember what was it. Okay, so at least two values match. Let me show you the solution for this. So the correct answer should be in the region of 45,000 to 47,000. How? Let me see it. So first of all, let me one second. Let me first move these things. Okay. So so that is your delta H V value. It is 40.7 kilojoules. So obviously you need to multiply it by 10 to the power 3 to convert it into joule per mole, because you require to calculate it in SI unit. Now coming back to R, obviously the value for R should be 8.314. The value for temperature, you don't have any problem, so you just need to convert it 25 degrees centigrade to, it will be, once again, 298 Kelvin. Fine. Next one, as I have said, you need to get the rho value in kg per meter cube. So the value 0.997 that is given here, it is gram per ml or gram per cc. But you need to convert it into SI unit to get a kg per meter cube. So just you need to multiply it by 10 to the power 3. Again, who has put the value for, I mean, it was like rho by m, right, for H2. Now we know that m for H2 is 18 in case of if it is gram, right? So it is not gram. Again, you have to convert that in kg as well. So again, you need to multiply it by 10 to the power minus 3. So if you have done all the conversion correctly, you should end up with a value like this. Okay. And to make sure what unit they have asked you to get. So you have to take a root of this 2.12 to 10 to the power minus 9, and if you take them outside the bracket, then they will be j joule m to the power minus 3 to the power half, and you will get a value like this. Okay, I hope so. Fine. Next question. So let us look at the question. Calculate RMS end-to-end distance for polystyrene chain. I think Arjun, you have asked like the number of bonds question, like what will happen if we take the polyethylene something. So this particular question should tell you the. I mean, you'll be able to clear your doubts. It has asked us to calculate the RMS end-to-end distance for polystyrene chain in a theta solvent at 25 degrees centigrade. What values are given? Steric parameter are given for polystyrene is 25 degrees centigrade, is 2.3. So now you know, once steric parameter is given, you have to consider the RMS end-to-end distance formula where steric parameters are involved, right? I mean, if it was not involved, there was no point in giving the sigma value for this particular case. So RMS end-to-end distance for polystyrene chain, I mean, it is considering a real life example where all kind of I mean, bond angle and short range interaction and long range interaction all comes in account. Here we are talking about a problem like that where we are considering a real life molecule like polystyrene, not like any freely joined chain or unperturbed chain, not like that, but a real consideration where every parameters are involved, like the bond angle parameter, sigma, everything. Okay, so you need to use those particular formula or that particular formula where sigma and other things are involved. And also do not forget they have stated it is a theta solvent. That will be very important. Molecular weight is given, sigma is given, temperature is given. You have to calculate it in nanometer. Okay, I already have one answer. Very good. I don't know whether it is right or wrong, but I have already one answer that is 35 nanometer. How to know theta? That you need to remember actually. I don't think many times it will be provided. Like it is styrene, like so you need to know the CC bond or tetrahedral angle in case of that. What is the CC tetrahedral angle? You need to remember that. Sorry. So I have two answer. One is 35, another is around 69 or 70. Okay. Okay, so let me quickly show you the solution. Why I'm showing it quickly, I will tell you soon. Okay. So at first, let me show you the solution and then I will tell you. Okay. So the correct answer was yes. I think Shanti Kumar. Yes, you were right. The correct answer is in the region 68 to 72. So the formula that you need to use here is this one. This particular one. Sigma into the power half L 1 minus cos theta 1 plus cos theta to the power half. Now,
Madam, madam,
yes.
instead of writing that 1 minus cos theta by 1 plus cos theta, it is better to write that as tan theta by 2. So the problem becomes, you can solve the
Hi,
problem
you
very
can solve
quickly.
that problem at like this. I'm just showing the equation like that.
That becomes
That
tan theta by 2.
hi,
1 minus cos theta by 1 plus cos
if
theta
it
is
is
tan theta by 2.
convenient for you, though you can do that. Na? If you look, you are supposed to know that it is equals to tan theta. If somebody doesn't know, you can't do it. So if you do know, then you can just directly go to it. So let me just quickly show it. Okay, fine. So you have your static parameters value, that is sigma. You know your L value, that is 0.154. Oh, fine. Sorry. And the theta angle that you are talking about, that you also need to remember this as well. Fine. The theta between the tetrahedral angle between carbon atoms, that is 109.5 degree. So it will apparently give you a value like minus one third. Okay. Please give me a second. I'm sorry for that. Sorry. Just one moment. Okay. Okay. So let us go back to the solution. Okay. Fine. So this is your overall solution. Now see, Okay, the theta value you need to remember, it is 109.5. That is the standard tetrahedral angle between carbon carbon bonds. Okay, so whenever you are solving a problem in the assignment or in the exam, you need to remember that. Next thing is, we already know we need to calculate the number of bonds, right? The sigma value is provided. L is, you know, 0.154. Theta value you know, so you can put this here. Only thing that you need to calculate is the value for n, right? So how can we calculate n? The molecular weight is given 10 to the power 6, and the this is your polystyrene, right? So this is the polystyrene, so this is the monomer, you know, the molecular weight of the monomer is 104. So your degree of polymerization, if you divide the molecular weight by the monomer's molecular weight, you will get the degree of polymerization value. Fine, but do remember that n is your number of bonds value. So what happens when a polystyrene molecule forms a polymer? It kind of looks like this, right? This is the structure for polystyrene molecule. So it has C double bond C. So how many bonds does one polystyrene molecule contribute? It contributes 2 CC bonds, right? Here, this is one bond, this is another bond. That means one polystyrene molecule contributes 2 carbon-carbon bond. Fine. So that's why after getting the degree of polymerization value, you know there are 9615 number of styrene molecules in this polymer. Each styrene monomer contributes 2 bonds. That means the total number of bonds will be 9615 into 2. So that will be 19230. So every time you are going to calculate n, you should also know the structure of the polymer as well, because this was different in case of polyethylene. We know the what is the structure of polyethylene, but in case we know that one styrene actually provide 2 CC bond. So that's why n is twice this amount. And when you put all the values, the answer will come in the range of 68 to 72, that is 69.5. Okay. So 109.5 angle, this is not you are getting, it is the standard tetrahedral CC angle. Okay. If you go through the structures, that how the carbon atoms are placed in case of a tetrahedral species, you will know the what is the angle between those carbons. It is a standard value. Okay, so uh, yes, you do require to remember the value for the bond angles, and you do require to know bond length. How can it be in degree, right? Bond length is 0.154. In the previous problem I just have stated it is 0.154, right? So how can L be in degree? So the theta value is 109.5 and the L value will be 0.154. So one second, let me finish the session up to now.